Hi. Someone somewhere has already solved your complex problem in a very cool and effective way. Wouldn't you want to know how they did it? That's an object of the talk today. Hi, I'm Michael Kalika, and today I'll be sharing with you a method that most of you probably don't know, using which you will be able to solve complex problems and innovate. And people who work around you will recognize you as a great innovator and someone who thinks out of the box, which ultimately might boost your career. And through my career as engineering lead, architect, and also a major astronomer, I solved many problems by myself, but not only that. I also help others to aim for the ideal results, and we'll talk about what ideality is, and also solve by themselves. So let's get started. So what we'll cover today? We'll cover what is TRIZ, how to look at problems from different angles and focus on what matters. I'll show you the algorithm or methodology how to think that will accelerate your innovation process. And I will show you some inventive methods using which you will be able to solve problems in engineering and also in business. How many times did it happen that you were sitting in a brainstorm session trying to generate ideas and nothing came out? Or it was maybe hard to start? It happens to most of us. And the reason is because innovation is hard. But what is innovation? So according to Merriam-Webster, innovation is a new idea. It's a creative thought. It might be imagination of some new device or method or process. And it's sometimes also viewed as application of better solution to a new requirement or existing needs. And the keyword here is better solutions to some problems. So innovation is a problem solving and problems that nobody has been ever to solve better so far. But why is it hard to innovate? So the paradox here is that experience and knowledge, sometimes they might be good and help us solve problems. Sometimes they might be bad and block our innovation. And why do they block? Think about how many times did it happen that you saw some solution to one of your problems and then you decided to go other direction, maybe because it's dangerous or you had better idea, you thought that you had better idea, or any other reasons. And then you saw that that particular solution works for someone else and worked very good. So that was frustrating, I believe. So the reason here is that our knowledge and experience sometimes hold us down. Try to recall as a kid, you sometimes encountered some challenge or problem, then you did trial and error, you overcome and learn from it, then you went to school, kindergarten, and or university, work, all of those. You learned a lot of information. And that information sometimes creates biases. And that holds us down like gravitational force holds us down, and we're not able to escape. So we need a way to escape and innovate. And TRIZ can help us in that. Imagine you are in an island and there is a hidden treasure in an island, and you are trying to find it. You might find it very fast, or you might spend all of your life looking for it and not find it. So finding a treasure is like finding ideal solution to your problem. And if you only had a map that could navigate you to that treasure or to your solution, wouldn't that be cool? So TRIZ could be that map. So what is TRIZ? So TRIZ is a Russian acronym, and it says Theory of the Resolution of Invention-related Tasks. Its history takes us to the previous century. In the middle of it, Genrikh Altshuler, Soviet engineer, he learned 100,000 patents. And during his study, he recognized that there are predictable patterns or methods using which it's possible to solve problems. And he also created algorithm using which innovation can also be accelerated. So what's the difference between TRIZ and brainstorming? So in brainstorming, we generate ideas, we shoot in all directions, then we evaluate them, and we select one, and then it solves our problem, maybe. In TRIZ, however, we go in a systematic way that navigates us to the ideal solution by overcoming psychological inertia and other constraints. So remember, brainstorm is random and TRIZ is systematic. That's a big difference. And you probably know how TRIZ works from our life. Most of you know what design patterns are, and TRIZ does for problem solving exactly what design patterns do for software design. From the bird eye view, we might have a particular problem, like how can I improve my application's speed? And then a generic problem in that case might be how I resolve contradiction between security and speed. Then my generic solution might be how to perform some process steps before they are required or currently done now. And then my solution might be how can I schedule security scans before the user interaction or when the application is idle. So it's also important to remember that TRIZ assists us in the thinking process, but in no way it's a replacement for the thinking process. It's like a smartest scientific calculator won't solve us a problem if we don't know math. So same as TRIZ. So let's talk about TRIZ basics. First, we have contradictions. So contradictions might be like security versus performance. It could be amount of information that we present to users versus ease of use. It could be system or data distribution like microservices or data sharding versus system complexity, and many others. So what people usually do when they encounter these contradictions, they either compromise or they do trade-off. And in TRIZ, we believe that trade-offs are our biggest enemy because we can resolve these problems without compromise. So we can have the cake and eat it too. Typically, what happens in contradiction, so we have two parameters, and that red curve represents our solution space. So any dot on that curve is not optimal. It's not good because it will sacrifice something else. So TRIZ can boost that curve and settle us for the best, because at any point in the new green curve, we are in much better shape and close to ideality than previously. But what is ideality? So according to the TRIZ, the perfect system or ideal system is when we have all the benefits at minimum cost and with minimum harmful effects. And we can describe it with this formula. So let's look at practical usage of TRIZ for some problem. So let's assume that we are a young startup, Hermes Deliveries, and we offer small, low-cost and fast deliveries by connecting people and couriers. From one side, we have customers. From the other side, we have couriers. And we developed very sophisticated and cool algorithm using which we can do matching or the perfect matching between customers and couriers by looking at history, different features, and lots of data. So customers place orders, then we have matching and acceptance. Our couriers receive push notifications, they accept the orders, and then they deliver it at the right time. What we learned so far is that 60% of our customers are leaving after 30 seconds of wait time, which is extremely bad. So what can we do about that? Meet Problem Explorer. So that's the first tool we'll use. We'll start with the original problem that we see, and from there we go broad. We'll try to ask, why do we want to solve this problem? And we ask that because we want to get into the broader problem. Because maybe something that we think that our original problem is not a problem, it's a symptom. So we want to have a 360-degree view. From the other side, we want to ask what is stopping us. and get to the narrower problems and focus on them. So in this case, we want to solve because of the customer attrition and because our couriers are not happy because they cannot plan their day. And then the broader problem would be revenue loss, risk of courier attrition. And from the other side, what's stopping us is that sometimes it takes a long time for the algorithm to do the matching, and couriers cannot accept orders while they're driving. So two narrower problems that we have is how to match orders fast and precisely, and how to accept orders fast and safely for couriers. So we'll start this thought process. That's the algorithm. So we'll start with two problems, and we will try to find contradiction of requirements. So requirements to our system. For the first problem, our requirement is how to match perfectly customers and couriers within 30 seconds. And those requirements are in contradiction, because if we solve one part, then we degrade another one. And on the other side, in the other problem, we want courier safety, but yet we want acceptance to happen within 30 seconds. Those are two of the requirements that are in competition. Then we'll ask ourselves, what is stopping us? In the first case, that would be the large amount of data that we need to process for the matching. In the second problem, that would be courier destruction that stops us. And now the most creative part in this. We need to ask ourselves how we make this thing that's stopping us to disappear. I usually advise my teams or people whom I work with to think like we have a wizard whom we can ask anything that we want without going into details how exactly it will be implemented. We don't care. The most important thing is to ask the right wish. So in that case, my first wish would be process large amount of data fast and accept orders without destruction. And then we're getting into contradiction of the properties. But properties of what? So in order to resolve this contradiction or make this something that stops us disappear, we need to change something in our system. And that something might be some entity, some process, something. And that something has properties. In that case, the first thing that we want to change would be a data process. From one side, we want it to support large amount of data. From the other side, we want it to be fast. And in the second problem, we want courier acceptance to be immediate, but without destruction. And from those contradictions, we'll now think about what resources are available to help us create the circumstances. And there might be many tangible or intangible resources like customers and courier features, data platform, ETL, streaming jobs, customer forms or time it takes to fill the form, price quoting, and many others. And then the ideal final result that we're aiming for. So customers place the delivery order and it's immediately accepted by the courier who is the best match. And in order to get into that ideal final result, we need to resolve this contradiction of the properties. And that's how we got to this contradiction of the properties where we started. And that's what we are aiming for. So now we can go into brainstorming session and start thinking, generating idea how to resolve those contradictions. But there is a better way. So in TRIZ, there are 21 parameters that can either improve or degrade in software. In other disciplines like engineering or business, these parameters are different and the number is different. So for example, we can have speed, accuracy, stability, ease of use, security, and others. So in our particular case, in problem number one, that would be amount of data and loss of time. And for the other problem, that would be a loss of time and ease of use. So those are generic problem now. So we're now operating in a generic space. And that's how I got to it. So fast is loss of time, immediate loss of time, and destruction is ease of use. Now I have 40 inventive principles, like our recipes or patterns that I could use. For example, I can do segmentation, take something out, merge something with something else, make something dynamic or self-service or anything else. But how would I know what the right principle to take and what to select? So ideally, I can, if I have time, I can go one by one and select few and apply a few of them and practice. But TRIZ gives me a tool called contradiction matrix. So it's a matrix where on one side I have these 21 parameters as improving parameters. On the other side, same 21, but worsening parameters. And the intersection between the rows and columns is a cell with numbers. Those are numbers of the patterns or principles that is best to start with. Let's see it as an example. So our improving parameter, what we want to improve is loss of time. Worsening parameters are amount of data and ease of use. So I decided to work with number 10, 7, and 25. Let's look at them. So 10 is nested doll. So nested doll is an imagination, of course. So think about it's kind of hierarchy. So it could be a menu in user interface. It could be indexes in database or some other form of hierarchy, maybe some structure, anything hierarchy. 7 is prior action. It's when we do some actions that will oppose or prevent undesirable effects later on. And 25 is self-service, when we make the system or function or process to solve the problem for itself. So let's look how we apply them. So our solution is like a tree with 3 branches. And let's see the first one. So first one is nested doll plus prior action. So what we can do is we can define metadata and classify or index our customers and couriers by various of features or attributes and do it in advance. We can, and then next, while customer fills the form, we can already know to which segment our customers belong to which features. And same, we can determine for the couriers who are in the same area and they're online. So we can do that perfect magic while customer fills the form. We don't need to wait them to hit on the submit. And the next one is self-service, auto-acceptance. Think about, like, as a courier, I can start my day and indicate in which areas and which time I want to work today. And that basically says that any order in that area and during that time could be streamed automatically to me and accepted automatically by me. No need to send me push notification, just schedule it for me, that's all. So it's a great win for couriers because now they have a peace of mind and they will not lose delivery or job opportunity because they are driving. From the other side, it's a great feeling for customers because they are filling the order and it's accepted by the best courier immediately. And that's the ideal target state that we're aiming to. By the way, Uber did the same for the drivers, the auto acceptance. So we used our existing resources without adding or buying or doing something complex. So we leverage everything that we had. And that's the biggest value of TRIZ. So I mentioned unseen resources. Let's look at them closely. What do you see in these figures? So most people will look at the black figures. But what if you look at the white ones? If you concentrate and look at the white figures, you will see that there's something is written here, and it's fly, win. And like now in reality, when we're looking at our system, there are tangible or intangible resources that we can leverage. So tangible resources in the software world, and again, software is also abstract word, so it's hard to say tangible, but yet. So something tangible could be data, hardware, some devices, logs, and etc. Okay, and intangible resources could be keystrokes, could be mouse movements, could be order of the elements in user interface, could be time while someone does something, which we can leverage, and many others. So how we find them? So there is a technique in TRIZ how we map and look at our systems in time and space. And other techniques, which I will not be able to go because this presentation, the time doesn't allow me. But if someone wants to learn more about it, please feel free to drop me a message, and I will be happy to share more. So why learn TRIZ and use it? So first of all is you. You will be satisfied because you will solve problems and very effective and cool way, and you will stand out in the crowd. Your customers will thank you because you will delight with wow solution and solve complex problems. And you will save time, minimize biases, and you will reduce trial and error. At Intuit, we have two core capabilities: is customer-driven innovation and design for delight. So using CDI, we select important and solved customer problem, and then we solve that during using D4D, and we do deep customer empathy using Follow Me Homes, using Go Broad and Go Narrow during rapid experiments. And in the recent year, we also used TRIZ multiple times and find it very effective. Who else used TRIZ? Apple, Hewlett-Packard, NASA, Samsung, and many other companies. So I want you to remember from this lecture a few things. So first of all, so there are patterns and algorithm for innovation. And then go broad and go narrow when you define problem. Look at it from different angles. Find contradictions. And always aim for the best or ideal final results. And remember that problem solving is actually contradiction resolving. Thank you very much. I'm very open for questions. So you could know that your solution ideal if you, before you start defining the solution, it's very important to define acceptance criteria and talk to your customer. So you know how you measure your ideality. So your cost, your harmful effects, and your benefits. That's very essential part before you start. So where could you learn about TRIZ? Is you can learn about TRIZ. There's a variety of books about that. Specifically in software, I can recommend Darrell Mann and a few other books that I don't remember author names. These are specific books about software. Other author I can recommend is Vladimir Petrov. He has many books in Amazon. And there's also plenty of information is available in the internet. It just, you need to learn and process it. So you don't necessarily need to, so when looking at the solution with the 14 innovation principles, is there a number you should shoot for? So in my particular case, I decided to use 3 out of 40. Usually you use few principles. Sometimes it could be 1, sometimes it could be few. There is no specific goal to use 3, 4, or 5. Just try to get familiar with them and apply them differently. You can even, if you are doing that together with a team, you can even divide and give some people solution, let's say nested doll, someone else you can give self-service, and ask people to come up with the idea how they could use, and then marry them.